Okay. Let's get started with current portion. What we were in. The current portion that we were in. We have seen charging of capacitor, combination of resistor. Correct, yeah?
Yes, sir.
We were in combination of resistor the other day. We saw for case of symmetry. We tried solving few questions also on symmetry. Correct?
Yes, sir.
Okay, we'll further it. And there are a few questions. There are a few configurations which are given configurations, though they are not part of theory, but they are so overplayed, we assume them to be part of theory. For instance, find what will be effective resistance of a cube. Generally being asked in SC1 also you will find it being solved, but we are to take it as a part of theory, and from this theory I'll articulate few questions for you. So firstly, we are assuming it to be an overplayed question, so it's a part of theory to us, and what we are to calculate here or what we are to derive here is a formula for effective resistance of a cuboid or cubical lattice. So let us begin with it. Write down. Let us take a cube.
So can you solve that triangle question you gave the other day?
Okay, the triangle question. The triangle question, I'll get you a hint and then see whether you'll be able to, during the course of class, solve it or not. If you are not, by the end of class, we'll solve it.
Yes.
Instead of the horizontal bar, there was a horizontal bar, correct?
There are many horizontal.
Bar? Check the horizontal bars on it. There was a horizontal bar, isn't it?
So, sir, there will be many.
So there are
Just a minute, just a minute. There was a register. We took this as the triangle, and then there was a horizontal bar. This is what I meant by horizontal bar. What you have to do, you have to first disconnect this point, disengage this point. After of disengaging this point, what we ought to do, we ought to look at this triangle, the inner triangle. Of course, you have a triangle which is never ending, a network of triangles which is never ending. But look at the immediate next. Is it okay, Sonnet? Look at the immediate next. Fine, Sonnet, respond please.
The upside down one.
The larger one, forget about the larger one. Look at the immediate next. This is the immediate next, correct?
Yes, sir.
And look at the immediate next from the perspective of points A prime and B prime. Look at them. Forget about the outer. You're discounting on the outer completely. You're looking at the next, the very next triangle. And the very next triangle has got its vertices as A prime, B prime, and C prime. Clear? And C prime to our suit, we can disengage as well. We know that we are free to disengage C prime. So this is what is the triangle for you, next triangle. And if you look at the next triangle from the perspective A prime, B prime, you will get to notice that it is nothing but the organic. It is nothing but the organic triangle ABC. It is nothing but the organic triangle ABC with the initial side length half of the organic. Agreed?
yes, sir.
I said initial side length. By initial side length, what I mean? A prime, B prime. Find ya?
Yes, sir.
Find Krish, find Sonnet.
Yes, sir.
So in this triangle, if I'm looking only at the triangle A prime, B prime, C prime, then I got to see that A prime, B prime, C prime is another unit which is akin to the parent and half of the side of parent, correct?
Yes, sir.
So if RAB is to be gotten, which is what author has asked, we can say that the inner triangle represents RAB whole divided by 2. You can replace the inner triangle following what was advocated the other day. Is it clear, Sonet? Sonet, respond. Sonet, where is
Um,
he?
I'm here,
Sonet, are you
sir,
able to
but
hear me?
I
Yes,
didn't
sir.
understand this part.
What is there not to understand there? You relate with what being taught, you will be able to understand. There is nothing. If you feel that you will not be understanding,
Okay,
trust
okay,
me, you will
okay.
never
So,
be
so
understanding.
like,
Let's go.
it's like that question where you did double. So we
Yeah,
took
of
two
course.
RAB.
Because
Okay,
there
okay.
it was double, here will be half. There
Yes,
it
sir.
was double, here will be half. That's it. I'm coming from the
And
beam, but got
it's
it
half
here?
because R is proportional to L.
Yes, because R is proportional to length was given to you. And then it reduces to a triangle which has got RAB to its disposal. You have to find RAB with the horizontal one being marked as RAB by 2. That's it. And here, so this will be R, this will be R, this will be R, this R, and this you can see 2R. This is what you will be getting. As I have told you, this is a question from Pluto. The answer to this is A rho root 3 minus 1 by 7, where A is the side length, rho the resistivity. So in a way, it goes to say that resistance will depend on length. Correct, yeah?
Yes, sir.
Is to say resistance will depend on length. So this is what you have, A rho root under 3 minus 1 by 7 as the answer. Anyway, that is the answer. You can always get to the answer following the methodology. Now you know what you have to do, correct? See for yourself. And yeah, what will you
Yes, sir.
do?
Yes.
RAB will be in parallel. First of all, these
Now
are
you.
RABs. Then 2R will be in parallel with RAB. Then that will be in series with 2R, and
And
entire
then
will be parallel with 2R. And that will get you again RAB. So of course we get quadratic equation, we know that very well. But that quadratic equation will lead to a very simple answer, as you can accept only one of the two answers. And that will be A into rho root 3 minus 1 by 7. Okay. I think I have some doubt on the answer. Let me check. I think root 7 minus 1 by 3. Just I'll check and confirm. I think root 7 minus 1 by 3. I wrote the opposite. Just a minute. Yeah, correct. Root 7 minus 1 by 3. This is root 7 minus 1 by 3. Idea? A
Yes,
row root 7 minus 1 by 3. Got it?
yes, sir.
getting it.
Okay, let's get then with the one which I am to take today started. We have taken a cube. Let me draw for the kids. We have taken a cube, and that cube has all its sides measured as R. The cube which has got all its sides measured as R. 27th is the day for your next examination. Am I clear? Please get this to Aditya also transpired, as I could not find him joining today. So 27th is the date for your test, the next, which will be based on current, electric current, with 30% backlog of electrostatics. Am I clear?
Yes, sir.
Ratio 70 to 30. Find here 30% the recurrent, the backlog, which is what I call cumulative. So 30% cumulative and 70% on the portion at run. Find here
Yes, sir.
27th. Please take a note of it. Okay. Now, what have we taken? We have taken a lattice. This is the lattice and it is cubical on shape. It is cubical on shape. And what we are to do, we are to find RAB. Now, what are A, what B? I'll let you know from here. I begin with this being A and this B. That means I'm calculating against body diagonal. Find here.
Yes, sir.
There are three cases against which we are to study the question at disposal. There are three cases against which we are to study the question at disposal. First one, body diagonal. Second one, face diagonal. And third, the edge. Find here.
Yes, sir.
We'll be studying for all the three cases. These are the three cases to which will relate a cube. Here, as it goes, every junction is separated by same resistance R. Every junction is separated by same resistance R. I'm not writing it, it will make my figure clumsy. Fine, yeah. That is understood. Fine. Implied meaning every edge you say, or every junction you say, the pair of junction is being separated by resistor R. Fine to all of you is good?
Yes, sir.
Okay, good enough. We feed current here. All of you please look into it. We feed current here and we want to take current out from this point. So I feed current here and I want to take it out, siphon it from this point. Now tell me, if I feed current from point A, think of the room that you are seated in and assume it to be a cube, not cuboid. Find here?
Yes, sir.
That you are seated in and assume it to be a cube, not cuboid. And then look at one of the corner of the room. Correct, yeah?
Yes,
Can
sir.
you look? Now, think current enters that corner. Fine?
Yes,
Think
sir.
that current enters that corner and the current is to leave your room by another corner, which is the body diagonal corner. Find, yeah?
Yes, sir.
Not face but body diagonal. Current is entering your room and it is to leave your room following another point, and that point to you is body diagonal. Firstly, current enters your room and the corner that you are looking at is to associate. I am to associate with that corner three paths. Right here?
Yes, sir.
Can we associate with that corner three paths? Yes or no, Pratyush?
Yes, sir.
Can we
Yes, sir.
associate corner, three paths to that corner?
Yes, sir.
Okay, now look at the three paths and look at it vis-a-vis. Please be very careful, mindful of what I'm saying. Look at the three paths and look at it vis-a-vis what you will find against the point of exit. Find ya. You are looking at the three paths, but from where? From where the current is to make an exit. Is it okay?
Sir, I
Okay.
don't understand. Sir, I don't understand.
You are looking, Krish, you are looking at the entrance of current. Fine. You
Yes,
have
sir.
located a corner of your room and that marks the entrance of current to your room, correct?
Yes, sir.
Now you are to look at the same point, but you are to look at the point being at the point of exit of current. Clear?
Okay. Same point as the exit.
Yeah. No. You are looking at the point of entrance and you are at the point of exit of current. See, there is a point for current to enter your room, correct?
Yes, sir.
That you fixed. Have you fixed it?
Yes, sir.
Okay, so current is entering there, correct?
Yes, sir.
Now you can be observing this phenomena from anywhere.
Yes, sir. Yeah.
Now, what I'm requesting you to do is to observe this phenomena from the point where current is to make an exit. Exit. Is it okay?
Yes.
And you know where current is to make an exit, correct?
Yeah.
Where
Yes,
is
sir.
current to make an exit? Body diagonal point, right there.
Yes, sir.
Yes, sir.
So where are you to put at? You are put up at the body diagonal point. Clear, dear?
Yes, sir. Yes, sir.
Yes,
Okay.
sir.
Now is not. Look at the three paths. Please keep on gaping. Is not every single path symmetric to the other two? Think about it. Is not every single, you have got altogether three paths, correct?
Yes, sir.
Pick on one path and look at it against the other two. Will you be able to distinguish this path from the other two? By that, what I mean to ask, will you be able to distinguish this path from this and this? Think about it. When you are at B, correct?
Sir.
Current entered at A. Current sees three paths in which it can divide. And current will divide in what fashion? I don't know. But I have to decide on the mannerism. How can we decide on the mannerism? Firstly, I have to place myself on the output point. So I have put up at B now. If I have put up at B, I get to see three paths which are, as seen from B, symmetric to each other. Counter me. Counter me if you have any doubt, please. Please counter me, because this is something which is for now intangible to us. Mathematically, when we'll make an observation, only then we can stand comfortable in our skin. For now, just by board representation, I won't be able to impress upon my point. That's the reason I seek help of your room. Okay, so please help me with your room. Look at your room, assume it to be a cube, and then think of current entering at one of the corner, and you are put up at the body diagonal corner. Correct, yeah?
Yes, sir.
Current sees three paths because current can move only through the edge. So current moves through this path. If current moves through this path, it encounters R, and then it sees a face. Correct?
Yes, sir.
If current moves through this path, it encounters R, and then it sees a face, correct?
Yeah. Yes, sir.
If current moves through this path, it encounters R, and then it sees a face, correct?
Yes, sir.
So can we say that current is to see symmetrical resistance value whichever path it takes? Think about it. Current is to see a resistance value which is even. Why did I say so? Here R and a phase. R and a phase. R and a phase. And not only and a phase. Also, that phase sees for all the phases that I am indicating, that phase sees at a particular corner the output. Correct? Yeah.
Yes, sir.
Furthest. Correct?
Sir.
So what
Yes,
we
sir.
now we can make a statement. And the statement being, if 3I is the current fed, you can take any current. I'm taking 3I. If 3I is the current fed, then I will pass through this phase and will through this, also through this. Anyone having any confusion on this part, please try to clear it off. I will pass through the three registers, and not only that, when current comes over here, following this line, when current comes over here, following this line, when current comes over here, following this line, they see a phase. Clear? Check it out here. This current sees a
Yes, sir.
phase. This one. This current sees this phase. Correct?
Yes, sir.
This current sees this phase. Correct or not?
Yes, sir.
Yes, sir.
Therefore, current at these points as well will divide symmetrically. By that, what I mean? This will see what current? I by 2. This will see what current? I by 2. Also here, this will see what current? I by 2. This will see what current? I by 2. How much will this see? I by 2. And how much this? I by 2. Okay, fine. Now, I will prove the same by another logic. And the other logic being, I
Sir,
set 3i here, and 3i will come out from this port, correct? Yeah?
Yes, sir.
3i will leave the lattice following this port, correct? Yeah?
Yes, sir.
Okay. So let me write 3i and ask you, if I do the other way around, if I am to follow reverse logic, by that what I mean, Krish, instead of siphoning current, I am to feed current, yeah?
Yes, sir.
So if I feed current, then how will current divide on these branches? Will the current be able to ever distinguish whether it is being fed from A or B? Think about it.
No, sir.
No, it won't be able to. So it will bifurcate in a similar manner how it did over here.
Yes, sir.
So
yes,
if
sir.
it is to part following a pattern, it reconciles following same pattern. I have told you, correct? Yeah.
Yes, sir.
So what shall I get here? I shall get over here I. What shall I get here? I. And what here? I. Correct? Correct or not? Think about it, yeah. What happened? Trish, Pratyush, Tanit?
Yes, sir.
Okay, so I here is what I want. Am I getting I? Yes, I am. I by 2 from here, I by 2 from here, it'll get me I, correct?
Yes, sir. Yeah.
Yes, sir.
And I by 2
Yeah.
from here, I by 2 from here, it'll get me I, correct?
One
I
second.
by 2
Yeah.
from here, I by 2 from here, it'll get me I, correct? Check it out here, check it out.
Can you explain it once more? That I by 2 plus I by 2 part.
If I am to feed current Trish from point B, correct? Then current as per what you did admit, it was your admission that current will not be able to distinguish, correct?
Yes, sir.
So current of course will not be able to distinguish because for current it is mere rotation by 180 degree, correct? Yeah.
Yes, sir. Yeah.
So it will not be able to distinguish. Thereby current will bifurcate in the similar manner as it did at A, correct?
Yeah. Yes, sir.
So I would have gone this way, this way. Were B be the point of feed, I would have got I, correct? But B is not the point of feed, B is the point of extract. So in what manner current will reconcile? It will reconcile in the same manner as followed when they are to be seen parting, correct?
Yes, sir. Yes, sir.
Good afternoon, sir.
In parting, they parted with I. So they will reconcile I this way, and I this way to get you 3I. Fine?
Yes, sir.
Okay. Now if I is over here, I over here, I over here, then I have to ensure that I'm getting I in this. I cannot be whimsical that I take I even if I'm not getting I in this. I'll have to prove that whatever line of argument we have taken is in commensurate with getting I over here, correct? Correct or not?
Yes, sir.
Okay, so let us see. We saw I by 2 this branch, I by 2 this branch. What current I'll get in it? I, correct? I by 2 from here, I by 2 from here. They will join to get you I, correct? Yeah?
Sir.
Okay. Here I by 2, I by 2. They will join to get you I, correct?
Yeah. Yes, sir.
Similarly, third one. This is the third one. This is the third one. I by 2
Yes, sir.
from here, I by 2 from here, correct?
Will give you I.
They will join to get you I. Find here.
Yes, sir.
So please see the distribution. This is how current is to get distributed. Today we are finding R equivalent by the process called current distribution. You can find R equivalent by many a process, namely line equivalent, plane equivalent, or point equivalent. Today, I am finding it first against current distribution. And then we'll go for how can we identify line or plane symmetry here. We'll be able to identify line or plane symmetry as well. But for now, we are trying to figure it out based on current distribution. Current distribution methodology is fool's proof methodology. It will not fail you. This is the methodology by which we get R equivalent for any circuit. And it is fool's proof. Yes, it is slightly lengthier than the other, but you need to exercise caution when you are using symmetry. Please see for that the symmetry part is clear, as I have predominantly used symmetry here. Current distribution, okay, but current distribution you will never get any inkling if you are not able to find a symmetrical case associated with circuit given. So that is what I have tried to identify, symmetrical case associated with circuit given, and then I'll write my equations against flow of current. So help me write equation. First equation is VAB is equal to 3I into R equivalent. Do you agree with this equation? This is for wholesome structure. This is for wholesome structure. What is potential difference across the cube per se? Potential difference across the cube per se is VAB, correct?
Yes, sir.
And what current we make pass through it? 3I. I don't know what resistance it will get me, but we can very well write Ohm's law, and that is to read VAB is equal to 3I into R equivalent. I don't know what is R equivalent. I'm blindfolded. I'm writing for entire of lattice a term R equivalent. Find here?
Yes, sir.
Okay. Now take any path. I'm taking this one. Take any path and try to write VAB. Look, this one, this one, this one. Visible here? Can you identify? Can you identify? Is it visible?
It's not that distinguishable, sir.
I'll try to get the brighter chalk, please. Brighter color. Is now visible?
Yes, sir. Yeah. Okay. Yes, sir.
I have taken this path, right, Krish?
Yes, sir.
And ask myself what will be VAB. I ask myself what will be VAB. What you have to tell me? VAB will be first one, I into R. Second one, I by 2 into R. Please look at it, class. I by 2 into R, correct?
Yes, sir.
And then the third one, what will that be? I into R. Look at it, class. Please look at it. Are you convinced? I'm just writing
Yes,
Ohm's
sir.
law. This time I'm not writing for entire of the lattice. I'm writing following a path. Of course, R equivalent I have not taken. I have taken potential difference across this point and this, then across this point and this, and culminating it with point B, correct?
Yes, sir.
Okay, so that is VAB for me. Now VAB from here will be how much? Tell me. 4 plus 1, 5, right? Yeah.
Yeah. Yes, sir.
So 5 by 2 I into R, right?
Yeah. Yes, sir.
VAB. And the two VABs can be equated, correct?
Yes, sir.
Yeah.
Get
Yes, sir.
me your equivalent and commit it to memory, please. Please don't make
Yes,
light
sir.
of these equations. These are of great import if the question is tweaked, because you ought to fall back to them if the question is tweaked. If not, commit the end result to memory. What will be the end result? Tell me what is R equivalent from here.
5 by 6.
Yes, remember this please. 5r by 6, correct, Krish?
Yes, sir.
Okay, good enough. 5r by 6. Okay, so from body diagonal, we go to face diagonal. Find ya?
Yes, sir.
This was body diagonal. I think you can distinguish between body diagonal and face diagonal, correct?
Yeah.
Yes, sir.
Okay. So this was body diagonal. Let us go for face diagonal next. Write down. Find R equivalent against face diagonal points. Find R equivalent against face diagonal points. So this being the case with us, this is the cube, entrance here, exit, right here, face
Yes, sir.
diagonal. I have taken the top face right here.
Yeah, yes, sir.
So face diagonal. Now, I would go by your understanding on symmetry. I'll go by your understanding of symmetry or on symmetry. Tell me, particular current enters. If particular current enters, then will it see this path? Please look at it. Symmetrical as this path, agreed or not? Think about it. I didn't say this path. I didn't say this path. Because this path cannot be said symmetrical to the upper face, correct? Yeah.
Yes, sir.
But look
Yeah.
at the other two line of movement. Please look at the other two line of movement. By that I mean this one and this one. Clear to all of you?
Yes, sir.
If you look
Yes,
at
sir.
the other, Aditya, are you here?
Yes, sir.
You joined late, Aditya?
Yes, sir. 15 minutes late.
Okay, what happened here? Got message late.
I had classes till 2 o'clock and then I had to have lunch, sir. So
Acha, acha, go fine. I wasn't known to this, dear. Aditya, what is
it's
your time nowadays?
I don't know, sir. They'll change again next week, so I'll let you know.
Okay, okay. Just let me know so that I can just pose in accordance, convenience of work.
Yes, sir. Sure.
Okay, then. So this is whatever current enters, the current is to leave that we know. I'm asking for can we assume that CB, ACB path is identical to a DB path? That is what I'm asking. Means I want to buttress my argument on whatever current will flow through AC will flow through AD, and the only which can substantiate my point is your understanding on symmetry. The only that I am banking on is how well is symmetric case understood by you. And for this, I will take help of the room that you are in again. I'll ask you to look at the roof. If you look at the roof, and if you take the point of entrance as one of the corner, and then the other corner on the roof itself, face diagonal, you take as point of exit. Find ya?
Yes, sir.
Then can you say or can't you say that this line will be symmetric to this line? Think about it.
Yeah. Yeah.
As
Yes, sir.
Yes,
symmetry
sir.
you are citing being at B. You are at B looking at A. Clear, dear?
Yes, sir.
Yes.
If you are at B looking at A, then you find two paths for current to bifurcate and they are symmetric to each other. Correct, dear?
Yes, sir.
Because we have taken this to be a cone. Sorry, a cube. So what can I definitely say is I will flow through it if then I should do this one. That's a given. If I flows through this, that is AC, then I will flow through AD. And what will flow through the other branch? I don't know. I'm marking it as I prime. Now, I switch my position with B. I was at A, I switch my position with B. I ask now current to be fed from B, correct? Yeah?
Yes,
Yes,
sir.
sir.
Current is fed from B. If current is fed from B, will it not bifurcate in a similar manner as it did at A?
Yeah. Yes, sir.
Think
Yes.
about it. It is to part. This current will part in the same fashion as it did at A. Therefore, I will move this way, I will move this way, and I double prime will move down, correct?
Yes, sir.
And I have told you the way that it parts is the way it takes to reconcile, right, class?
Yes,
Yes,
sir.
sir.
So what should fall, what should flow through CB? I. What should flow through DB? I. And what should flow this way? I double prime. Please do check the distribution, all of you. Convinced?
Yes,
Yes,
sir.
sir.
And if you are convinced, then you will allow me, let me mark this first, small a and small c. You will allow me to uproot D small a and C small c. Why will you allow me an uproot? Because they are not to see current flowing through them. Why
Yes,
and
sir.
how did I say so? I comes over here and I goes this way, correct?
Yes, sir.
I comes at C, capital C, and I leave C for B, correct?
Yes, sir.
Therefore, capital C, small c, capital D, small a, these are the edges which are not to see current flowing through them.
Yes, sir.
Yeah.
So they are non-functional. They don't function. They are non-existence to you. And if they are non-existence, let us make them so. They are not seen around. They are in absentia. And if they are in absentia, we get a very simplified circuit at disposal. Or effectively, we get a circuit which is much simplified. Please see for yourself. This is a simplified circuit for you. What you can say easily now. This R and this R is series, correct?
Yes, sir.
Yeah. Yes,
This
sir.
R and this R in series, correct?
Yeah.
Yes, sir.
2R in parallel with 2R here.
Mm-hmm.
What you get? I'm simplifying it for you. 2R in parallel with 2R right here.
Yes, sir.
And then you have R over here. So you can mark it over here. This is R. R down. R from this side also down. So R down. Okay. And then coming to base. Base will be a replication of top. Correct here?
Yes, sir.
Yeah.
So 2R here and 2R here. And here, these
Yes.
are the ones which we have got. We know which one is the entrance and which the exit. Can you tell me what will be the effective resistance then? Can we mark the entrance and the exit first? Can you mark this as the entrance and this as the exit? Any problem? Check it out, please. Fine. Very good. Are all of you good with it?
So, 1 second. Yeah. Yes, sir.
Any point, you can take this point, any point. Because they are all at same potential. So any point can be taken as inference. This point, this point, this point, up to this. This point, this point, this point, anything. Okay, please do check and accordingly convince me on your read for R equivalent. What is R equivalent? Find it out, please. Aditya, what is running with your school?
So wave optics. Ray optics, sorry.
Ray optics.
Yes, sir.
Okay, and what are the chronology that they are following? Ray optics. They began with ray optics, correct?
No, so electrostatics, and then they went to ray optics.
Is it parallel track or they are done with electrostatics?
Parallel track.
Parallel track.
3 hours by 4.
3 hour by 4, correct. Correct. So that is what we get against face diagonal. Against body diagonal, you have Mr. Aditya, that is 5 hour by 6 we got. Okay. I'll
Yeah,
see
I was there.
up with you, no issue. 5
I
hour
was
by
there.
6. Yes, dear.
I was there for that. I saw it from this.
Achha, you saw. Okay.
Yeah.
5 hour by 6, 3 hour by 4. Okay. I like to know from all of you what is the portion running at school. If you want me to juxtapose as per one portion which is common with all of you, I'm good with it. I don't have any objection. It's not that I'll be following whatever is there organically in hierarchy to follow. I'll go by your school, subject to condition that your schools are running the same. If they are running different topics, we cannot be scattered with different topics without completing with one. Right, yeah? So just check if your schools are running, if they say that all of them are to see, all the schools are to see optics running at this point in time. So after of current, we can go for optics, no issue. If not, then I'll follow the organic methodology and the organic chronology being after of this, we should go for EMI, electromagnetic induction. Right, yeah?
Yes, sir.
So that is for you to decide. You just let me know. Fine, Aditya?
Yes, sir.
Okay. So 3 hour by 4 for this, and let's culminate it with the last one. Write down. Find R equivalent. Find R equivalent for the circuit shown. For the circuit shown against an edge of the cube. Find R equivalent for the circuit shown against an edge of the cube. So this is the cube at disposal class, and this time we are neither going with body diagonal nor face diagonal, no diagonal, but edge. So this is where current enters the lattice, and this is where it leaves. Entering point, leaving point. Okay.
Hello,
Yes, dear.
sir. Can you just repeat? Actually, I got disconnected.
Okay. This is the point where it is entering, Pratyush, and this is the point where current is leaving. That's it. It's the same lattice. It's a cube, and this time we are reading it against one of its edge. Is it okay, Krish? Sorry, Pratyush.
Okay, sir.
So current enters and leaves. Yeah, this is a different case altogether, but we'll try to figure something out here as well. And that will be based on how conversant we are on current distribution process. So let me ask. Firstly, from A to B is a completely different ball game altogether. Can we say that? A to B, there is no
Yes.
symmetry which you can cite. So what will you say? Let some current flow through it, and that current I am marking as I prime. Please do check, class. Find yeah.
Yes,
Because
sir.
AB path is non-symmetrical. You can see for yourself. Please do. AB path is non-symmetrical, but is symmetrical. A, C, and AD. Again, look at the room that you are seated in, please. And try to get this somehow possible, fine, not possible. You can brood over it, no issue. You can contemplate. We say contemplating tea leaves so that we can do later. For now, if you are able to, then try to understand If not, you will contemplate the tea leaves later, and if there is any hitch, we'll get back to this. Surely we are to get back to this. For now, what I'm saying is, if I have got current and it's to be fed from the top, one of the corner of roof, and taken out from the same edge bottom point, we get to see symmetry not being there between AB, of course, but certainly we can go or vouch for symmetry of AC and AD. We can vouch for symmetry of AC and AD. When I say symmetry, what I mean to say is current will have equiprobability. Current will have equal probability of treading AC or AD. And probability of current is beholden by resistance that it is to encounter. Probability of current, even on current, the probability of being even is based on resistance that it is to encounter. So the implied meaning being, if it follows AC path or AD, it is to encounter same resistance in coming out of the point B. It is to encounter same resistance in coming out or when it tries to make an exit through point B. That is what I'm trying to advocate for. If not, no issue. You take different current, you will end up getting same result. Yeah, you'll have to write few equations. That's it. And that if you want, we can take it that way as well. If you want it to be taken I1, I don't have any issue. I'll take it I1. If you want it to be taken I2 because you're not convinced on symmetry, take it I2. I don't have any problem. But if you take it at I1 and I2, then certainly I do have my rights on this being and this being what? That right I do have. You can decide then I can extract on this being and this being what? Let you again. Think about it.
Your voice is echoing.
There is echo.
Is it? I think it's from not my end. Is it from my end?
Okay, now it's okay, sir. Now it's okay.
Is it good now?
Yes, sir.
So
Yes,
why
sir.
did we take I1, I2?
I can take it to be the same. I was trying to get an endorsement from any one of you. You didn't say so. Otherwise, I can take this as I and this also as I. Because
But
they
sir,
ought to be same. There is no point they will be different. This will be I and this will also be I. They are ought to be same. Even if you are taking I1, I2 with few more equations will prove the same. That is, this will be I and this will also be I. Whatever is this will be this for sure. There is no two way about it. Okay. Now let me ask you. If I comes at D and I comes at C, or I1 comes at C and I2 comes at D, in what manner, according to you, it will divide? By that, what I'm asking you is C symmetric to D or not? Think about it. C falls on a face. Look at the
Yes, sir.
face. Look at the
Sir,
face on which
by
C
space.
falls. C falls on a face which contains A and B. Agree?
Yes, sir.
C falls on a face which houses A and B. And D falls on the face which houses A and B. Correct? Check
Yes,
here.
sir.
D
Yes, sir.
falls on the face, this is the back one, which houses A and B. And D also falls on the face, which houses A and B. Correct?
Yes, sir.
So
Yes.
C is symmetric to D. C
So
is
yeah.
symmetric to D. By that, what I mean, if I1 already taken. So if I3 moves down from D, if I3 moves down from D, then I3 only will move down from C.
Yes, sir.
Then I3 only will move down from C. Is it okay?
Yes, sir.
Now what current we are left with in this branch? Think about it. I came, I3 down, correct?
Yes, sir.
So in this one, I minus I3, agreed? Or I2 minus I3. You can
Yes,
write
sir.
it as I2 minus I3 as well, no issue. Here I came, I3 went down, correct?
Yes,
I
sir.
came, I3 went down, correct class?
Yes, sir.
So what current in this one? I minus I3 or I1 minus I3. Find ya?
Yes, sir.
Okay. I minus I3, I minus I3. They come over here, agreed? Check it out here. Check it out. I minus I3, I minus I3, right here?
Yeah. Yes, sir.
sir.
They come over here and then will flow down twice of I minus I3, correct?
Yes, sir.
Okay, look at the branches, the vertical branches. I prime, I3, I3, and this one twice of I
So,
minus I3, correct?
so one doubt, I3 will not be
Yes.
equal to I by 2, no, sir?
Which one, dear? I3? No, no.
No, no, sir. Okay.
We if I take I, if I take I, Krish, then we can argue on it. Okay? If you take I over here, then you can argue on it will be I3. But you can't say that it will bifurcate symmetrical.
Okay,
Why?
yes.
Why? See the paths, they are different, correct?
Yeah, yes, sir.
So we can't say it will be equal to I, right?
Okay.
Okay. Now twice of moves down, and you are known to what will flow in this and what will flow in this, correct?
Yeah.
You know that in this should get me, what should I get finally? I, correct here? Tell me yes or no.
Yes, sir.
Because I only did flow. And what should I get in this? I, correct here? Think about it. Think yes or no?
Yes,
Yes,
sir.
sir.
Okay. Now I3 from here. So I3 should combine with what to get you I? I minus I3, agreed here? I minus I3, I3 will get you I, correct?
Yes, sir.
Sir.
So in this branch will flow I minus I3, and this branch will also flow I minus I3. So twice of I minus I3 split. Twice of I minus I3 split. And I minus I3 moves over here, I3 down. You get I in this one. And I3 down from here as well. I minus I3 from this side, you get I in this one as well. Now your argument was, why will I take I? I will take I minus I1. You can take I minus I1, no issue. Then also you have to end up getting same result. See for yourself. If I write I1 minus I3 here, correct? And from
Yes, sir.
here, what do I write? I2 minus I3, correct?
Yes,
Yeah.
sir.
Yes, sir.
Then through this will flow, I1 minus I3 and I2 minus, what was it? No. I1 minus I3, yeah, I2 minus I3, correct?
Yes, sir.
They will come over here, correct?
Yes, sir.
Okay, and what I want final current to be, tell me. I want
Sir.
final in this to be, what I want, I3 is coming over here. I3 is coming over here. So I want in this I1, correct?
Yes, sir.
Or I2, whichever you take. If you want I1, I2, you get I1, I2 from here. See, I3 is coming over here. So I1 or I2, if you take this, I2 will match with I3 to get you I2 here.
Yes, sir.
If it is I2 minus I1, I3. Correct? Check it out.
Yes,
And
sir.
if this is I1 minus I3. Then again I3 from here will get me I1. Correct? Yeah.
Yes,
Yes.
sir.
So you can take either. You can take this, or you can be of the opinion that I1 will be equal to I2. Find, yeah.
Yeah,
Hmm.
yes, sir.
Okay. So we got this. This is the distribution. Yes. Here you need to write few equations very carefully. First one, VAB is equal to, now total current that I have fed, twice of I plus I prime. Agreed? Yeah. Check it out. If I take I1 equal to I2, then twice of I plus I prime. Total current fed is this to the lattice.
Yes, sir.
Into R equivalent, VAB will be this total current into R equivalent. One equation. Equation number 2. VAB will be I prime into R. Agreed?
Yes, sir.
I prime into R. That is VAB.
Yes, sir.
Okay. Few more equations we can write. And please do check. VAB this. I wish to move on the top loop. And why? Fine. First VAB. One more VAB. Let us write one more VAB. Okay. VAB. From here to here. I into R, A to D. A to D. I into R, agreed?
Yes, sir.
Yes, sir.
T to this point. I3 into R. I3 into R, D to this point. I3 into R.
Yes, sir.
At this point to this point. I into R again, correct? Yeah.
Yes, sir.
I2 we have taken as I. So I into R, check it here. Here to here, here to here, and here to here. Find here?
Yes, sir.
Okay, so there are three equations with us, but we have not got, we are yet to get R equivalent. In order to get R equivalent, I'll have to bring I prime and I in terms of VAB. In order to get R equivalent, I'll have to bring I prime and I in terms of VAB. So that I can do with I prime from here itself, correct?
Yes, sir.
Because I prime can be replaced by VAB by R. Agreed? Yeah.
Yes, sir.
So VAB by R, that is okay. Can you help me getting I in terms of VAB? You will say yes, we can. We can get I in terms of VAB subject to the condition we get I3. Correct?
Yes, sir.
We get I3 in terms of I, then we are sorted. We'll be able to get I in terms of VAB. I want to get rid of VAB, so I want VAB here, I want VAB here. Are you getting it? And then I can strike off. Correct? Yeah.
Yes, sir. Yes, sir.
Okay, so I prime is sufficing. But I cannot express in terms of VAB because third equation has also got I3 in it. So can anyone suggest how can I get rid of I3? Or how can I relate I3 with I prime or I?
I3
How
is
can
I only.
I relate I prime and I? Any one of you? I prime and I. I. Can you take this face, top face?
I3.
Hmm.
Top face, can you see the top face?
Yes,
Yes,
sir.
sir.
Okay. What are the currents flowing in it? I minus I3, twice of I minus I3, and I minus I3 in one direction, and I3 in the other direction, correct?
Yes,
Yes, sir.
sir.
Okay. Write KVL. What I get? I minus I3R, twice of I minus I3R, I minus I3R, minus of I3 into R is equal to 0, correct?
Hmm. Yes, sir.
Yeah. Yeah.
Why minus?
I minus I3 into R against these two. Then twice of I minus I3 into R against these two. Then I minus I3 into R against these two. Now when I go up, I find current in a different direction. Correct?
Okay, okay.
So minus of I3 into R. Correct here?
Yes,
Yes,
sir.
sir.
Yes,
So
sir.
let's get that down. What do we get? 1 I minus I3, 2 and 1 again. So 4. 4 I minus I3 into R. Right here?
Yes.
Minus of I3 into R is equal to 0. Please endorse me on this. Is it fine?
Yes,
Yes,
sir.
sir.
Okay. 4, 1, 2, 3, 4. So 4I minus I3 into R minus I3 into R is equal to 0. And this will help me get I3 in terms of I. Correct, class?
Yes, sir.
So 4I minus 4I3 minus I3 is equal to 0. So 4I is equal to 5I3 is what we get from here. I3 will be replaced now in this equation. VAB is how much to us? VAB is twice I into R plus. Now I3 will be 4 by 5. I into R. Please do check, class. Is it fine?
Yes, sir.
From here, I3 replaced 4I by 5 and whole into R is what we have done. Okay, now you have the equations with you. Shall we write that down? So VAB is what to us? First one. Twice of I. I want a replacement. How can I replace I? This, can you tell me how much will it be? 10 plus 1, 14, right?
Yes, sir.
14 IR, correct? 14 IR by 5. Okay. 14 IR by 5. So I want to replace I. What will I get? 5 VAB by 14. 5 VAB by 14 R, correct? Yeah?
Yes, sir.
Okay, so 5 VAB by 14 R. Please do check once. Please do check.
Twice.
Twice as well, huh? Yeah, correct. Correct. It will be twice. Okay. Fine, dear?
Yes, sir.
5 VAB 14 R. Now I prime, please. I prime is VAB by R. So let us write that down. VAB by R. VAB you can strike, isn't it?
Yes, sir.
Yes, sir.
Pull into R equivalent. Wait a minute. Pull into R equivalent, right? Yeah.
Yes, sir.
And please multiply it with R equivalent. Okay, VAB we can strike off now. This is the R equivalent. VAB we can strike and get R equivalent. Please do the needful. Get me R equivalent from here, all of you.
So is it 7R by 19?
7 or
19. Is it?
12.
7 or by 7 or
12.
by 12.
7R by 12. Right. Correct.
Yeah.
Correct.
Yes, sir.
Correct, sir. 7R by 12. R equivalent will be 7R by 12. So please commit it to memory. Body diagonal 5R by 6. Face diagonal 3R by 4. And edge 7R by 12. These are the value, and these are taken as theory, so much so that when matrix used to be a very frequented question in IIT JEE, then they have asked you questions, institutes have asked you questions, giving them in matrix form. This edge, the other edge combination, and to the right 5R by 6, 3R by 4, and the other one. Fine. Also, you can take a note from here which will get you the least resistance. So, which is to encounter, which combination is to encounter for current least resistance? What will you say?
Edge.
Yeah.
The edge. And the maximum?
The maximum will be for the body diagonal.
For the body diagonal. Fine, dear. So this is what we have for the cube at disposal. Let's take a few more questions. Write down, class. Given R1, R2, given R1, R2, find, given R1, R2, find R equivalent, find R equivalent for circuit shown. Given R1, R2, Find R equivalent for the circuit shown. Can you tell me on distribution of current class? How will current get distributed? Let me mark them. A, B. This is C to S, this is D to S.
So the resistor in the middle has.
Is R. We have taken it as R. That also is known, but my question is over here positioned merely on current distribution. So R1, R2 being known to you and they are same. R1 over here, R1 over here. This is crisscross arrangement. So we have crisscross arrangement here of R1, R2. I just wish to ask, what current relation do AB share with CD? What current relation will AB share with CD? Just that much, nothing beyond it. What will it share? AB with CD. Whatever you feed into this lattice, you can feed whatever you deem into the lattice. My question being limited to, what current relation will AB branch share with CD branch? Any one of you?
It shouldn't be the same.
Yeah, it'll be the same. It is ought to be the same. Because if I prime is to flow here and I double prime is to flow here, when you flip the circuit, it will bifurcate in a similar manner. Correct, yeah?
Yes.
Yes, sir.
Bifurcates in similar manner. So I prime is ought to flow through this one and I double prime through this one. As you know, bifurcation and reconciliation, they are in the same fashion. Correct, yeah?
Yes, sir.
Okay, so they have bifurcation over here and then it will reconcile. So we can say over here, after this, what you have to do, that is as per the language of question. But the distribution of current says that whatever is to flow through AB will flow through CD and whatever is through the other branch will through the last branch or the leftover branch. Okay, now if R equivalent being asked, what we should do? In this case, if R equivalent being asked, what we should do? We should write KVL equivalent and get to R equivalent value. We can get R equivalent. Fine, let me stretch it. Let me ask you what will be R equivalent for this combination. Tell me R equivalent for this combination. Find R equivalent. What will you say? Let VAD equal to I into R equivalent. First equation can be? This is
Yes,
A,
sir.
this is B, correct?
Yes, sir.
So
Yes, sir.
VAD is equal to I being fed. Yes, Aditya?
Yes, sir.
VAD,
Yeah.
I being fed, so I into R equivalent, one equation.
Yes,
The
sir.
other we go through this one, the top one. VAD is equal to what to us? Is equal to I prime into R1 plus I double prime into R2. Okay. Done. Next we go through this one. So VAD is what to us? VAD is I prime into R1 plus. Now you'll have to tell me what current should I take flowing down or up this? If I'm taking down, so what current will flow down? From I prime, I double prime goes. Correct, yeah?
Yes, sir.
So what should flow through this? I prime
I-
minus I double prime. Correct?
Yeah.
sir.
Yeah.
And to that I double prime will add to get you I prime. Correct, yeah?
Yes, sir.
Okay. So I prime minus I double prime whole into R plus finally I prime into R. Okay, dear?
Yes, sir.
Yes,
Okay.
sir.
These are the equations which you have, and from here you need to get R equivalent. Please see how many unknowns we are having. I prime we don't know, correct dear?
Yes, sir.
I double prime also we don't know, right dear?
Yeah.
And we don't know, what else we don't know? We don't know
R
R,
equivalent.
we don't know R equivalent. I we know because I is nothing but I prime plus I double prime, correct?
Yes, sir.
So I is not an unknown, you can write it down over here. I prime plus I double prime into R equivalent. So how many unknowns do we have here? We are having 1, 2, 3 unknowns, correct?
Yes,
Can we
sir.
solve to get R equivalent? Can you check once? Can we solve to get R equivalent? 3 equations, 3 unknown. These are general questions which are being asked. Therefore, if we know the answer to these questions, it adds to our repository. Not a harm if we know answer to these questions. R1, R2 combination, crisscross combination. Will you be able to further this?
Uh,
Yeah.
Yes, sir. Yeah,
Yes, Chris, you're saying something?
No, sir.
Will you be able to further this? For
Yes,
R
sir.
equivalent?
Yeah, yes, sir.
Please, anyone having SC Varma?
Yeah, I have, sir.
Please flip to SC Varma questions. There are good questions on circuit in SC Varma found. Can you check the circuit questions, Krish?
Sir?
Can you check the circuit questions in SC
Yes.
Varma, solved and unsolved both? There are many questions, Krish, many a question. Check.
Yes, sir. Lots of that.
There are a lot of good number of questions on circuit. Correct, dear? Solved as well as unsolved, right, dear?
Yes.
Would you please help me mark the pages?
Sir,
From-
so the page is from where circuit starts.
yes.
So 1 second, yeah. Sir, it starts mainly from from 189.
189. It goes up to?
This is solved ones.
Yeah, solved as well. They are equally good questions, the solved ones.
Solved
Yeah,
one, it starts from 189 to
194.
yeah, 194. Yes, sir. After that, it stops.
Please go through these questions, class. They are good insight on circuit. The solved ones in particular in SC Varma. Okay, it will make a very good solution to you, and it will be few of them at least will be for your retention. For example, ladder, we should know what will be the answer, root 5 minus 1 by 2. The other triangle that I raised, also answer why should be known to us those questions. They can be a direct ask in objective question. I have got one question, very good question from Ayurdu. A very important question from Ayurdu. And that question is on infinite network. That question is on infinite network. Have you ever been to amusement park and got to ride striking cars?
Yeah.
Yeah, yes, sir.
So if you have driven striking car, not nowadays because nowadays they are using a different methodology altogether. But yesteryears there used to be a pole behind of the striking car, and that pole used to connect to the roof. Have you ever seen that?
Yes.
Yeah, yes.
The ones which you get in the bowling alley nowadays. Bowling alley uses different technology. There is no roof to which it connects. The striking car connects. Have you seen a striking cord connecting? There is a tail, and that tail is a
Yeah.
rod. That rod connects to the top.
Yes, sir.
Yes, sir.
And that top network was fed with current. The network at the top was fed with current. And if the current flowing through branches are not kept even, then a striking car will be biased to move in a particular direction. So if you want the striking car to be even on any direction, then the network that you have should see same current flowing through every branch. And that you can realize if the network is of large expanse. That means the network is spread and is spread for good dimension. Then you can realize it. And generally we used to get those networks only. So the practical being this, in actual, if you want to be unbiased, then you'll have to take a network which is spread up to infinite dimension. And that is what Ayurveda has placed a question on. He says that there is a network which spreads up to infinity. There is a network which spreads up to infinity. Find equivalent resistance. There is a network which spreads up to infinity. Find equivalent resistance between 2 points very near to each other. I am drawing the network to you. Find equivalent resistance between any 2 points which are close to each other. So this spreads up to infinity. And if it doesn't spread up to infinity, then is a bone of contention to me. It'll be a really pain in neck to solve if it doesn't spread up to infinity. I'll get you a question and then you will realize on your own. But if it is up to infinity, it eases our work a lot. And that is what I am to prove over here. He says that this is the point A, this is the point B. And every branch has got even resistance R everywhere. Find what is R equivalent. R equivalent when you look at this lattice against A and B points. When you view this lattice against point A and B, what will you get R equivalent equal to? Tell me, class, will you be able to figure it out? What will be R equivalent equal to? And as I have advocated through the day on current distribution methodology, I'll make no departure. I'll be on current distribution methodology only. But to current distribution methodology, I have something to add, and that is called principle of superposition. Third place, I told you. I'm using in laws of motion, I will use in wave, and then I'll use in current. So this is the third place in physics in our preparatory course material, where we are using principle of superposition. And what is principle of superposition? Principle of superposition being here, if I am to find VA minus VB, I am to find, that means I am to feed current at A and I am to take current out at B. That is what author has told me, that you take ports as A and B. And if you look from the ports A and B, then what is the total resistance which you get? Similar to what you had in Q. Correct, dear? Ports were given to you and then you have to find R equivalent, right, dear?
Yes, sir.
Here also ports are given to you A and B and you have to find R equivalent. The only problem, it is a flat surface, laminar surface, and it spreads up to infinity. So how will you go about it? Here I make good of principle of superposition. How I make good of principle of superposition? We assume input at A, but output at infinity. Clear? What I say? We assume input at A. Am I clear, class?
Yes,
We
sir.
assume input at A. Find here.
Yes, sir.
Yes.
And where is the output? Output is at infinity. Find here.
Yes,
Hmm.
sir.
So input at A, if you feed current at A, and current is not to see where to come out from. Current is absolutely clueless where from it is to leave this lattice. Then tell me, if I drop current, if I drop you at the crossroad and you don't know which way to head, then will I not say that you are equal on probability to head in any direction?
Yes.
Yes, sir.
Yes, Valodia.
Yes, sir.
Yes.
So current I being dropped here, it enters the lattice, and current doesn't know which way is to make an output. So what will it do? If I is what I am feeding, I by 4 will go this way, I by 4 will go this way, I by 4 will go this way, and will go this way, I by 4. Agreement class, check it out there.
Yes. Sir.
And why did I say so? It is even on direction. Why so? Output is not visible to it. Find here?
Yes, sir.
Okay. So input at A and output at infinity. Input at A, what does it mean? Please read it properly here. Input at A and output at infinity gets us VAB equal to I by 4 into R. Agreed?
Yes, sir.
VAB. I am calculating VAB.
Yeah,
But
yeah. Yes, sir.
input is at A and output is at infinity. So what do I get in this branch? I by 4. I by 4 multiplied with R will get me VAB. Correct here?
Yes, sir.
So doubt.
Yes, yeah.
So can you explain the output at infinity part?
Yes, sure. See, input, I am feeding input anywhere. Anywhere. I am feeding input to this circuit. And output I am taking from that point at a very remote point. Far flung from the input, output is far flung, remote from it. And if it is remote from it, current enters, current is clueless, absolutely, absolute blank, absolute oblivion. Which direction should I head? I want to make an exit, but which direction should I head? I don't know. So I'll read this as current finding equal probability for output, of course. Therefore, it will bifurcate in 4 equal parts. It has got this path, this path, this path, and this path to follow. So it will bifurcate in 4 equal parts. I by 4 goes this way, I by 4 this way, I by 4 this way, I by 4 this way. Remote, very far, not visible is the output. And there is only one input, that being A. Please don't confuse yourself with B being the output. B is no more the output. Output is at infinity and A is input. Yes, I'm calculating VAB, that we can always do by finding potential difference, and potential difference will depend on current product with R. So I by 4 is current and it is multiplied with R to get you VAB. But this is when input is at A and output at infinity. Correct, Dea? Correct, Sonet?
Yes, sir.
Now let us take the other way around here, which is input at infinity and output at B. I repeat, input at infinity and output at B. So input is at infinity, so V infinity, and output is at B, so VB. This will get me VAB as. Now, coming to the slides again. Okay, blinker on. I'm not able to see it. What I see? I see current coming out of B. Clear?
Yes, sir.
And If I feed current to B, you know in what manner it will bifurcate. So whatever manner it bifurcates, same manner it is to reconcile, correct? Yeah.
Yes, sir.
Yes, sir.
So what current will come out from B, that I know is I. But how will it come out following the branches? How will it come out following the branches? This branch will see I by 4. This branch will see I by 4. This branch will see I by 4. And so will this I by 4. So input at infinity, output at B gets me VAB again equal to I by 4 into R. Please do check class. Again we get VAB as I by 4 into R. Pay heed only to the yellow mark chalk piece. Clear here?
Your screen is frozen.
Okay. Is it? Any help? No.
No, sir. It's still the same.
Aditya, is the screen frozen?
Yes, sir.
Frozen.
Yes, sir. That's why I'm exiting and joining again.
Sir, now it is okay.
Is it? Acha. Just check once.
Yeah.
Again,
I can't see the screen. I can't